Hey guys, what's up? And I hope you're all doing well out there. So here we're gonna have a look at the maths paper 1 pure maths, and this is for the AS maths paper. So try not to be confused with the actual paper 1 for the just the pure A level. For this syllabus they've actually split this up. So now if you're doing AS, you will not be sitting the same paper as those from doing the full A level, and the questions are also quite different. As you can see, with question 1 you're doing with tangents, but the question for the other paper, for the other sample, is actually to do with differentiation and calculus and so forth. So without further ado, let's kick in. So here we're going to do a complete walkthrough, and as usual we have 2 hours. Well, not as usual, this is the first time, but yeah, let's jump in. So number 1, so the line L passes through the points A and B with each given coordinates. Find an equation for the line L. Okay, so I put a nice little hint there which says y equals mx plus c. Now when you have an equation like this is a straight up tangent or straight line equation cutting through 2 points. So always visualize 2 points like here, like A and B, and then just draw a line connecting them. That's how I do it, and I always think this is a straight line because it's meant to be a line. Now when you want to use y equals mx plus c, all we need is the gradient m. To find the gradient m, it's just simply the change in y over the change in x, so the change in y coordinates over change in x. And looking at the coordinates here for A and B, we can see that y is 1 and minus 2. So the change here will be 1 minus 2. And the change in x would be 3 take away 4. So 3 minus 4. That's it. And now when you put this in the calculator, well, you should get 3 over minus 1. So the gradient here is minus 3 over 1, or minus 3. So that's easy. Now therefore, all we do is just plug this back into our equation so far. So we're going to have y equals minus 3x plus c. Now this is what we got so far. Now all you want to do is find what c is. Well, a nice way to do this is firstly rearrange the equation to make c the subject. So if I plus 3x across, we're going to have y plus 3x equals c. Now all we do is just pick any pair of coordinates and just plug in the values of x and y, and voila, you get c. So I want to go ahead and pick A because it's easier. So when x is 3 and y is 1, we're going to have 1 plus 3 times 3. And this is going to give us 1 plus 9, which is 10. So therefore, C equals 10. And that's it. So therefore, the equation for L is y equals minus 3x plus 10. Voila. This is one way to do it. And of course, there's always various other ways. But let's go. Okay, number 2. Ooh, this is easy too. So the curve C has equation over here, which is a nice good old quadratic. Now here we need to find the gradient of the curve, which is here, y equals 2x squared and so on, at the point P where x is 5 and y is 6. Now easy. To calculate the gradient, all you have to do is realize that firstly, the gradient is always used as the letter m. And m in this case equals dy over dx. It also equals the change in y over the change in x, as you've seen in question 1. Now, when it comes to an equation like this, like quadratics or cubics, you could use both, but in my case, I would just use dy over dx. I would differentiate this equation, firstly. So let's go ahead and differentiate. So 2x squared becomes 4x. The idea is to drop the power down and subtract it by 1. Next one, 12x becomes just 12, so it'll be minus 12. And finally, 16 becomes 0. And that's it. Now all you do is realize that you want to find the gradient at this point. So we could say, alright, so at point P, we know that we have x is 5 and y is 6. Well, you only have x to use. So we could say therefore m equals 4, and then at the point x equals 5 minus 12. And that's it. Then you just plug in. So you got 4 times 5 is 20, minus 12 is 8. So the gradient of the curve at this point P, when x is 5, the gradient is 8. That's it. Easy stuff. So given that the point A has position vector 3i minus 7j and the point B has position vector 8i plus 3j, find the vector from A to B. So that's what it symbolizes as, A to B. So what I did here, I just said, okay, let's call this vector here little a and this one little b, just to give it a name. And now the definition of A to B is literally like this. So from this coordinate A and this coordinate B, we have some given position, which I called little a and little b. Now from finding A to B, you just have to find pretty much b minus a in simple terms, yeah, b minus a. And what I do is I always convert these into columns. So 8i plus 3j can be written as 8 and 3, where top is x and bottom is y, or I and j, minus the a, which is 3i and 7 minus 7j, so 3 and minus 7 for the i's and j's. And that's it. Now we just subtract. So 8 take away 3 is 5, and 3 minus 7 is 10. So the position vector, or the directional vector, is the correct term. The directional vector is 5, 10. Easy. Now B, find the magnitude of this vector. So the bars always means magnitude, yeah? That literally is telling us to use Pythagoras theorem to solve it. Or to make your life easy, we can say, okay, the general formula is simply the distance formula. So it would literally be 5 squared plus 10 squared. So essentially essentially the distance formula or Pythagoras. Yeah. Now giving us a simplified third, well, just put that in your calculator. And when I did that, I got 5 root 5. So let me write down 5 root 5. That's it. Easy stuff. So yeah, guys, I want to say, if you guys are finding these videos helpful, just give me a like, and yeah, share this to your friends, and subscribe even. Okay, guys, number 4. Let's check it out. So here we're given a cubic equation as a function. So we know it's cubic because it begins with an x cubed term. Now the question tells us that we need to use the factor theorem to show that x minus 3 is a factor of fx. So yeah, so essentially to show something is a factor, you just have to plug in the value of x equals 3 into this equation. And when you do that, and if your function at x equals 3 equals 0, then we can say that yes, this term is a factor. So really, we just want to prove that we get 0 remainders. So when we factorize this, you can factorize it no problem. That's really it. But anyway, when you do plug in x equals 3, you do indeed get 0. So remember, it would be 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. In your working out, always write it like this. So say, okay, f3 equals 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. And then say this equals 0, and then make a statement. Say, yes, x minus 3 is a factor of fx. It is a factor of the function, literally. That's it. Now, part B. Hence show that 3, in other words, x equals 3, is the only root of the equation when the function is set to 0. Okay, so to prove this, we need to use long division now, because we want to show that when we divide this, we can get firstly a quadratic equation, and then we need to show that we cannot factorize a quadratic equation, because that's the only way to show that we have one solution, which is 3, x minus 3, that is. Anyway, let's go ahead and do some long division, see what we get. So first things first, to start this, we will ask ourselves, how many times does x go into 4x cubed? Well, it goes exactly 4x squared times, because 4x squared times x gives us 4x cubed. Now all we do is just multiply this out. So let's do this. So 4x squared times x minus 3 will give us 4x cubed minus 12x squared. So that's good so far. So weirdly enough, you actually get the same result. Now subtracting this, you get 0, which is actually again very weird. Now we drop this down and we should get plus 2x here. And now we put the 0. Now we ask ourselves, how many times does x go into 0? Well, this would be 0, so we have to put a 0 term here. So now we say, okay, 0 times the x minus 3 term will give us 0 plus 0. Wow. I'm not really used to this kind of long division. It's usually a lot more intense. Now we subtract this and you're left with 2x. Drop the minus 6 down. So you got 2x minus 6. Now once again, we ask ourselves, how many times does x go into 2x? Well, it goes exactly twice. Times in this, you get 2 times x minus 3, you get 2x minus 6. And yes, subtracting this, you get no remainder. So actually, even though this looks weird, this is actually correct. Now what do we have so far? So now we got 4x squared plus 2 as our final quotient. This is our solved solution. So we can say that this term here times x minus 3 will give us the fx function. Okay, so we can say therefore, so just summarizing this, the function can be factorized to x minus 3 and 4x squared plus 2. Now, at this stage, we cannot actually solve this any further. You can take the 2 out of this. So if I just bring it to the front line, we're going to have x minus 3, and we're going to have now 2x squared plus 1. You can, at this stage, you cannot factorize this one, because this one, you can't really do much. If you set this one to 0, for example, just to prove that you can't factorize it, if you move minus 1 across, you're going to get 2x squared equals negative 1 divided by 2, and that's the problem. You cannot square root negative number. So in this case, you cannot get a solution. So that's it. So that therefore we can pretty much say that x minus 3 is the only solution, because when you set this to 0, you can get a solution, which is only x equals 3. That's it. That's really how you solve this kind of problem. But yeah, if you guys so far have enjoyed these videos, you know, please give me a like and tell your friends about it, and of course subscribe, you know, as always. And, okay, number 5. So given that the function equals 2x plus 3 plus 12 over x squared, where x is greater than 0, show that when you integrate this function with these set limits 1 to 2 root 2, you get this answer here. You get an exact answer. Now to do this straight away, to integrate, you firstly got to make sure that all your terms are on the ground, that you have all x terms on the baseline and there is no fractions or and such forth. So first things first, let's change 12 over x squared into something standard, yeah? So we can say that the function is now, of course, 2x plus 3. And now if we move x squared to the baseline, we can call it x to the negative 2. Because that's what we do. When you raise it up, you just switch the power to a negative sign. Now, let's just integrate this, yeah? So integrating this function from 1 to 2 root 2, plugging this in. Well, what do we get over here? Well, this is easy, yeah? To integrate, you just basically increase the power by 1 and divide it. So 2x becomes 2x squared over 2. 3 is like x to the 0, so it becomes 3x to the power 1 over 1, which is the same. And the last one, 12x, it becomes 12x to the, you know, if you add 1, it would be minus 2, it would be minus 1 over negative 1. And then we just put the limits down. 1 and 2 root 2. So what I would personally do is firstly try and simplify this, yeah? So inside the bracket, we're going to have x squared plus 3x, and this is going to be minus 12 x to negative 1, or bring x to negative 1 underneath, will be minus 12 over x. And then you put the limits in, yeah? Alright, so thankfully you can actually put this all in the calculator once, which is a good thing. If you put 2 root 2 at once, what do we get? So what the way, just to show an exam, do it like this, yeah? So you can say when x is 2 root 2, so 2 root 2, you should get answer squared plus 3 answer minus 12 answer. You should get firstly 8 plus 3 root 2. You can put it underneath when x is 2 root 2. So always give a reason, and then the second one would be minus, and then when you plug in 1, so you're going to have 1 equal, so you can have 1 plus 3 minus 12. So you can get minus 8. So these are your two solutions. This is here when x equals 1. So it's always like that. It's always the upper limit minus the lower limit. And when you plug this all in, well, you can clearly see that 8 minus 8 is 16. And then you can have 16 plus 3 root 2. 16 plus 3 root 2. Easy stuff. Oh, not bad. Now let's move on to 6. Question 6. Let's go. So prove from first principles that the derivative of 3x squared is 6x. Okay. Now first principles, all that really means is that we need to use the definition of a limit. And one key thing to know is that when you take the derivative, it's always using dy over dx. In other words, the change in y over the change in x. That's always how we find a gradient. So think of the change in y and change in x as in two coordinates. That's what we have from x to something known as x plus h, where h represents, you know, the extra distance. Same with the y coordinates. We've got fx and fx plus h. Now, to make your life easy, when you have this, put this formula down. So this is the difference between both the y's and the x. And the limit is always set to 0 because we need to think that the gradient is always a flat slope. Okay, that's why it's 0, because the gradient is a flat slope. Now, let's go ahead and plug and play. So if fx is 3x squared, that means f at the point x plus h is going to be the same thing, but replace x with x plus h. So let's go ahead and just do this step by step here. So this fraction, so fx plus h is going to be 3 times x plus h all squared minus fx, which is 3x squared, over, so we've got x plus h minus x, where the x is cancelled out, you're left with h. Now, let's go ahead and try and tidy as much as we can, yeah? And oh yeah, the 3, we can take we can factorize the 3 out. So just taking 3 outside, let's take 3 over h outside, yeah? So take out h as well outside, so we're going to have, make it clear, 3 over h. Now what do you have inside? So you've got x plus h all squared, so expanding this x plus h squared as a quadratic, you should get x squared plus 2xh plus h squared, and then you minus it against x squared. Okay, hope you guys are following. If you're not following so far, just remember this was over h, but I just took it outside, yeah? Now looking at this one, we can start simplifying this, so cross this out, so bang, bang, and you're left with 2xh plus h squared. Now what we could do is realize that we can, if we multiply 3 over h across, we're going to have 3 over h times 2xh, which will give us 6xh over h, where the h's actually cancel out. And lastly, you got 3 over h plus h squared, which is just, well, 3h, because 3h squared over h is 3h. That's it. Now we go ahead and apply the limit. So when we can say that when h approaches 0, 3h becomes 0, because remember, you just substitute h with 0 and you're left with 6h. So this cancels out. And that's it. We proved the definition of a limit from first principle. Hey guys, welcome to another one. So number 7. So here we need to find the first 3 terms in ascending powers of x of the binomial expansion of 2 minus x over 2 all to the power 7, given each term in its simplest form. This is very easy, honestly. This is very standard. But if you're not sure how to do binomial expansion, I would really recommend you learn this formula here. This is a formula I adapted and pretty much made it general. Because if you're actually deciding to do the A level instead, well, unfortunately, if you're doing AS, you can only do AS. But if you're doing for A level, you could use this one and adapt it for the second paper. Anyway, let's have a go and understand what's happening. So we're given 2 minus x over 2. The key idea firstly is to make it 1 plus or 1 minus at least. So 1 needs to be important here. To do this, we need to factorize the 2 outside the bracket. So let's go ahead and do it over here, yeah? If we're going to take 2 out, well, and because it's the power 7, we take 2 to the power 7 out, meaning inside we're left with 1 minus, and if we take 2 out of here, we'll be left with x over 4. That makes sense? Because 2 times x over 4 gives us x over 2. And all of this to the power of 7. So far so good. So now this part here looks a bit like the 1 plus ax term, where you got 1 is 1, and now you got minus a quarter, which is a, and you got x, and n is 7. Now all you do is literally just plug this into the formula. So we can say, okay, therefore, and just sticking 2 to the power 7 in front of it for later calculation, we can say that the binomial expansion is going to be 1 plus, and instead of n, we're going to have 7, so 7 over 1, which is 7. Ax, so a is going to be literally minus quarter x, or we can copy the whole thing, minus x over 4 to the power 1. And that's it. Plus, and then we do the second term. We've got n times n minus 1, so we've got 7 and then 1 back, so 7 times 6 over 2 factorial because there's 2 terms, and then same thing, minus x over 4 all squared, and so on. If we had more terms, we'll carry on. Yeah guys, and that's really it. So now that you've already solved this, all you do is expand it carefully, you know, multiplying each term as it is, and when you do that, you should get this, you know, literally simple as that. 128 minus 224x plus 168x squared. And you can just write plus dot dot dot, indicating that of course it goes on for more terms, but we just want the first 3 terms, and voila. Now B, let's finish this off here. Explain how you would use your expansion to give an estimate for the value of 1.995 to the power 7. Well, you just have to use your answer here to pretty much work that out. So this is our expansion we need. But what it means is that, first things first, when you look at this figure, you need to notice that this figure here is kind of similar to the original expansion here, the original bracket, I mean, before it's expanded. They both got power 7 actually, and the only difference is the inside term. They kept it algebraic and they actually gave you a number here. So all you essentially need to do is really say, okay, let's equal this and find the correct x value to give you this. So what I did, I equated them. I said let 2 minus x over 2 equal 1.995, and I solved for x and got 0.01. Now all you do for x is literally plug it back into this equation, and when you do that, you're going to get some estimate of this one up until for the first 3 terms. So just literally plug in your x value into this equation. So it looks like this. So 128 minus 224, instead of x, 0.01 plus 168, 0.01 squared. Okay, have a go, you guys. And I'm gonna quickly just do it right now actually. So I should get 128 minus 224 answer plus 168 answer squared. Oof. So I got, okay, that's what I got. How many decimal places? Alright, so actually the calculator is fixed. You get 4 decimal places. So I got 125.7768. That's it. All done. Yeah, so far guys, as usual, if you're enjoying this video, please give me a like and subscribe, and give me some feedback if there's anything else that's not clear or you want me to teach in a slightly different way. I'm all ears, so just let me know, yeah. But yeah, other than that, let's move on to 8. So let's check it out. Okay, so it looks like a nice triangle question. So before we even read this, I think we should just work out this extra angle here. So we know all angles in a triangle adds up to 180. Got 60 and 70 makes 130, meaning we've got 50 left here. Okay, and they seem to give us one length of 30. Now let's read the question. So a triangle lawn is modeled by the triangle ABC, okay, and the length AB, which is the bottom here, is 30 meters long. So given that we know the two angles, calculate the area of the lawn to 3 significant figures. So to find the area of the lawn, which is basically a triangle, always use this formula, which is the half AB sine C. This is literally the area of the triangle, and I always picture it like this. If this was side A and this was side B, then angle C is in between. It's always the angle between A and B. So suppose we got this angle here, we should just find one more length. If we found this length here on the left side, then we pretty much have an angle between two lengths. Now to do that, to find any of these angles, I would use the sine rule, because you can take the relationship between the ratios of the length and the angle and solve. So let's go ahead and call this length x, yeah. So to find the relationship, we could say, okay, and the sine rule looks a bit like this. It's always some length over a over the angle of itself, opposite angle, equals the length b over the sine of its opposite angle. So let's go ahead and use it then, yeah. So let's use x and sine 60 because they're opposite, so we get x over sine 60 must be equal to another pair, so 30 over sine 50. Okay, easy stuff. And then just solve for x. So just times sine 60 across, so you got 30 over sine 50. Oh yeah, be very careful. Make sure your calculator is in degrees mode, yeah. So always in degrees mode. I don't know, it depends on each calculator, but there should be an option to switch out radians if you have it on that. But if you don't know what I'm talking about, then your calculator is probably nice and fine. But yeah, so for x, I got exactly, well, roughly 33.92. So keep it into 2 decimals or 3, or leave it unrounded if you can. And then now you got this length. So if we redraw a triangle, we can say, okay, we got 70 between two lengths, x and 30. So x is 33.92 and 30. And now we just plug into the formula here. So we could say we got half AB sine C, we got half times 33.92 times 30 sine 70. So doing that, half times answer times 30 sine 70, and you should get to 3 significant figures, 478. What's the unit? Meter squared. Yeah, it can't be centimeter because it's actually a garden. Yeah. So for part B, so why is your answer unlikely to be accurate to the nearest square meter? So this is one of those thinking questions. Now, logically speaking, and I've checked the math scheme to just confirm this, sometimes you don't have to necessarily answer the actual square meter, because the general idea is to put this in a real context. So this is talking about a 2D map of a lawn. Now, if you think about it, if you look in your garden, there's probably a good chance that your garden isn't 2D, so it isn't flat. And it's probably going to be a bit bumpy and might have a few hills or whatnot. So the area actually might not be correct. This is the area on the baseline, but the area could be a lot greater because there might be a greater surface area or higher hedging. So you could say, for example, as the math scheme would say, that the land or the lawn itself is not flat. So you could just simply say not flat. You know, various other reasons around it, just by the shape of it being not entirely 2D. Another answer that they also suggested was 4 significant figures. Now this one, just what it really means is that your figures, that if we calculate it properly or incorrectly even, we won't actually get the correct 3 significant figures, or even so, it's unlikely to be exact, as they might grow or the hedges might grow. But either way, I think the best answer for this one is to just look at the shape and just wonder, realistically, in the current situation, would our garden be 2D in this form? That's it. Anyway guys, yeah, I hope you guys enjoyed this video and this little explanations. If there's anything else you want to add to, especially part B, let me know in the comment section. If you enjoyed this video, please give me a nice big like. And yeah, share with your friends, your mates, your buddies, everyone. And yeah, otherwise I shall see you in the next question. Ciao. Welcome back guys, and here we are, question 9. So what's happening here? So it tells us that we need to solve for the given range of angles. So this is very specific, from 360 to 540 degrees, and we'll get to this in a second, of the following equation. So this trig equation can only be solved using trig techniques. Okay, give your answers to 1 dp. Now, one thing I want to note, every time you do these type of equations, always write down your identities that you think is relevant. Typically there's 2, yeah? You have the sine squared x plus cos squared x equals 1, and you also have the fact that tan x also equals sine x over cos x. So these are literally the 2 identities that it's recommended to learn by heart every time you walk into these kind of questions. Now, when you look at the equation itself, the only way we can solve this is to firstly recognize that this one kind of looks like a quadratic equation, except that you have a sine and a cos. Now, the only way to actually make this work is to realize that, hey, we can change sine squared x using the lovely sine squared plus cos squared equals 1. So when you make sine squared the subject, you can throw cos squared to the right hand side and make 1 minus cos squared, and then bang, substitute this back into this expression like I did over here. So this becomes that. Open this up, expand it up carefully, so you get 12 minus 12 cos squared, and so on, and then throwing everything to the right hand side. So again, this is just for convenience because I like to make my squared terms positive, and then you get a simple quadratic equation. So instead of the usual x squared plus something x plus a constant, you're going to use cos x squared, cos x and a constant. And by the way guys, it looks the same. Okay, this is literally a blatant quadratic equation. Now once you got this, now we can solve it. So to solve this one, you could factorize it or use a quadratic formula. I'm going to go ahead and use the quadratic formula because it's just easy, yeah? So you use the quadratic formula, which is minus b plus minus the square root of b squared minus 4ac over 2a, where a is 12 from here, and then b is minus 7, c is plus 1. Plug it in, and then using the plus and minus function in your calculator, or just plus and a second minus, you should get 2 solutions, a third and a quarter. Now, make sure your calculator is in degree mode, yeah? Not radians, because we want it in we want the actual degree angles. So when you do that, when you cos inverse a third, you should get 70.5 degrees, and if you cos inverse a quarter, you should get 75.5. Your calculator might say arc cos or cos to the power negative 1. They're both the same thing, yeah? So your calculator should be either written like this, or could be written like this. Okay, both of these are the same. It's just definition. It's just different regions, different calculator regions have different way of writing it down, just different notation. Anyway, here comes the main bit. So now I didn't actually solve this, so this is what we're gonna do together. So now that you got the solutions for x, for cos, we need to use something known as the cast diagram to plot this in and find the correct angle for this range. So what I did is that because we worked with cos, we can draw the cast diagram, which is CAST, always in this order, yeah? So from this angle, going like this, yeah? Now, because we're using cos, this means that we're going to use C, and because it's the answer that we had a positive result, we're going to use A, because A always means all, and all means positive. And you can kind of guess, C is for cos, T is for tan, and S is for sine. Okay, so we're not going to use these two, yep? So we just got these 2 roots. So this means the way this works is that we firstly draw 2 lines like this and label these angles x, because this tells us that we have an angle width of x. Now, the way this works, always start off 0 degrees here, and now we just draw circles. We always work anti-clockwise, yeah? So keep a note, we always travel in this direction. So first things first, we start from here and we go to here and we say we traveled x degrees. And then we draw another line and we say we traveled almost a full circle, but x degrees less. So we also traveled 360 minus x degrees. And then we can do another one and so forth and say we traveled all the way around until we hit the line and say we traveled a whole circle plus x degrees. So the way this works is that we can just do several loops until we keep hitting the lines over and over again. Now, you can just go this far because the reason why, because if we do a full circle is 360 and if we do 1.5, we know that this goes up to 540 degrees. So 180 or 540, yeah? So 180 if it's half a circle, 540 if it's a full circle and a half. So that's our limit. So it's literally the limit from here to here. Since we understand, and yeah, this is literally our answer, guys, 360 plus x. And that will give us our answer for the result between here. So 360 plus x, what's it going to give us? It's going to give us, if x is 70.5, 360 plus 70.5 will give us, I should know this mentally. Well, 430.5. So yeah, there's always two answers to give here. And if you replace 75.5 with x, you can also get 435.5 degrees. And that's it, guys. That's literally all you need to know about cast diagrams. Okay? If this was understood, please let me know, because sometimes it's a bit challenging to illustrate this. But the whole purpose is that every time you get angles, whether it's cos, you label C. If you get tan, you label T, and sine, you label S. And that's what you work with. You always do A plus one of the trig functions. That's if the result is positive. If we had a negative result, then you don't use A. And then you wouldn't use the function given. So if it was cos x equals negative a third, we don't use cos of A. In fact, we use S and T. But anyway, that's another day, yeah? Otherwise, let's move on to 10. If you guys enjoying this, give me a like, yeah? I mean, that helps a lot. Anyway, let's move on. So the equation kx squared plus 4kx plus 3 is 0, where k is a constant and has no real roots. Now, this is a discriminant question, okay? This is involving the quadratic equation, but in particular the square root function. It's basically telling you that when you have no real roots, this means your calculator will give you an undefined answer. That means if you get a negative inside the square root, you cannot get an answer. So that's what it means by no real roots. So in other words, b squared minus 4ac inside the square root must be negative or less than 0. So this is the equation we begin with. Now, prove that we can get this answer, that k is between this. So all we do now is just replace the b squared minus 4ac with the letters from here. So b is obviously 4k, so we can say therefore we got 4k squared minus 4ac, so 4 times a, which is k, times c, which is 3. And all of this is less than 0. Now let's keep going. So expanding this one, we got 4k squared, so that's 16k squared minus 4 times 3 times k is 12k. Okay, and you can kind of figure out, you can see that we've almost got the answer. So factorizing k from here, so just solve this like you always do. So you got 16k minus 12 less than 0. So this means our result is going to be either, well, the critical points are going to be k equals 0 or 16k equals 12, which is k equals 3/4. And that's it. And because it's less than, and the way it usually works, if you had the graph, so say this is the quadratic graph, which is something like this. Oh god, that's that's awful. It's a typical U-shaped graph, yeah. Oh god, bear with me, guys. It's literally going to be when the function is below 0. So and the only times below 0 is this region here. And we can see that one of the critical points is 3/4, because that's what we got, and the other one is 0. So the answer will be 4 between 0 and 3/4. And that's it. I think that's it. Let me see. Yep. 0 and 3/4. Done. Okay guys, number 11. Let's have a look. So here they want us to prove that for all positive values of x and y, that we can show that the square root of x and y is less than or equal to the sum of x and y over 2. Okay, alright. This one isn't as bad as it looks, okay? Usually this kind of equation is very, typical for you to just use one letter as the other. And my advice for these kind of questions is that every time you're involving x and y and they want to show that at least positive values and negative values, it's always a good idea to somehow replace y or x with the other letter. Usually it happens all the time. So let's do this. So I said let y equals x. This means that the left hand side now is going to be x times x, or y times y. So let's just change it to x, yeah? This would be the square root of x squared, okay? Which is less than or equal now to x plus x over 2, which is 2x over 2. Okay, not so bad now, is it? Not so bad. Now, here comes the other bit. So now when you square root this function, x squared, what actually happens? You're actually going to get a plus minus x, which kind of makes sense here, doesn't it? A plus minus x. And whereas on the right hand side, you're going to get the 2's cancelled out, so you're left with just an x. So yes, it looks like, firstly, the positive x does equal x. However, if it was negative, it is definitely less than x. And that's it. That's literally proved. So therefore, this literally tells you that it's possibly be proven this way. So now we just say for any positive value, so we can say, okay, suppose x equals 1. This means we could have negative 1 is less than or equal 1, or plus minus 1, or plus minus 2 is less than or equal 2 if x was 2, and so on. So yep, it works. The right hand side will always certainly be the same or bigger than the left hand side. Okay, that's it. That's literally all we do. Now, next one, B. Prove by the counterexample that this is not true when x and y are both negative. Alright, this is simple because we just pick values. So I'm going to go ahead and choose x equals minus 1 and hell minus 2. I know this is like the obvious picks. So when you plug in minus 1 firstly and minus 2 on the left hand side, we're going to get minus 1 times minus 2, which is plus 2 by the way. So we're going to get root 2 on the left side. Now we're going to check if it's less than or equal to the right side. So if you've got minus 1 plus minus 2, you're left with minus 3 over 2. So false. So this means that this does not work for negative numbers. So it's actually done. So we proved it by a counterexample that this is not true. And that's it. That's literally all we do. Anyway, guys, if you found this question helpful, again, give me a like as always and subscribe. Otherwise, let's move on to 12. Okay, number 12, guys. So a student was asked to give the exact solution to the following equation here. So this is a typical power equation, yeah? The student's attempt is shown below. So the first line is the same. Now, the second line, however, is wrong. And again, this reflects to part A. Identify the 2 errors made by the student. So the first error is this one here. This little bit here. Why? Is because the actual power equation, 2 to the power 2x plus 4, is actually 2 to the power 2x times 2 to the power 4. Reason being is because the only way to add the powers if the base numbers are products. So if you have 2 to the power something times 2 to the power something else, you may add the products. So that is the first error. So we have to state that down. This one should be this, which in turn will give you that. Second one. Now let's assume this is right. Let 2 to the power x equals y. So therefore y squared minus 9y plus 8 equals 0. Okay, let's see that's okay. So if you got 2 to the power x is y, this means 2 to the power 2x is y squared. So this is y, that means squaring this one and sticking a 2 there, you can add a power 2. So you're just sticking powers of 2 to both. That's cool. Minus 9y, that came from here, so 9 times y, that's correct. Plus 8. Now what's 2 to the power 4? 2 to the power 4 is 16. Oh god. 2 to the power 4 is 16. So this is of course wrong. So that's your 2 errors. That means the answer is obviously wrong then. Now, B, find the exact solution to the equation. So I think let's do this ourselves carefully. Yep. So if we're going to use all the things we used incorrectly. So going back to the first equation, this will be, we're going to split this up into powers. So it'll be 2 to the power 2x times 2 to the power 4. 2 to the power 4 is 16. So we have 16 bracket 2 to the power 2x plus minus 9. And then 2 to the power x equals 0. Now we said that let 2 to the power 2x, 2 to the power x equals y. This means we're going to have 16y squared because we've got 2x here, minus 9y because it's just a regular 2 to the power x. Okay, this looks quite easy now. So all you do now is just factorize. So factorize y out. We'll be left with 16y on the left side and just a 9 on the right side. This means our first solution will be y equals 0 or 16y equals 9, which will give us y equals 9 over 16. And can you simplify that? Yes, I think you can. Oh, no, you can't. Well, just leave as 9 over 16 actually. Well, let me check my calculator. Yep, 9 over 16 obviously. So since we got 9 over 16, therefore x equals something. So now we just replace the y with the 2 to the power x. So this means therefore, if y is this, that means 2 to the power x is 0, or 2 to the power x equals 9 over 16. That's easy. Therefore, to get this to fix up completely, we now need to take logs on both sides, yeah? For the first equation, if you take logs here, you'll get a maths error. So actually, this would be it. So this one has no solution. If you take logs on both sides here, the trick is if you're not sure how to do it, you can just say log 2 to the power x must equal log 9 to the power 16. 9 over 16. And using the properties of log, if you've got a power inside the bracket, you can use this power and put it in front of the log. So it'd be x log 2 equals log 9 over 16. And now you can just divide log 2 across. So we're going to now have x equals log 9 over 16 over log 2. Yep, and that's pretty good so far. Now, just to be extra careful to see if there's any other steps we could do. Yeah, could we do anything? No, not really. Actually, you could. What you could do, you can convert this to a single term. If you have a log term over another log term, so for example, log a over log b, we can write this as log b, the baseline, and a. So the b here can be re-represented over here and cross L. This means 2 can go over there. So we're going to have, therefore, x equals log, I mean, this is just another way to write it. I don't think you get penalized. So that alone is also a correct answer. Log 2, 9 over 16. Yep. And yeah, I think that should be fine. So factorize completely x cubed plus 10x squared plus 25x. So I've gone ahead and done it already. But the trick is to realize that we're just working with x's firstly. So to factorize x is easy. You're left with x squared plus 10x plus 25. And now looking at this quadratic, you just need to pick, open up two brackets and realize two numbers that multiply to make 25. And well, that's going to be, of course, 5 and 5, because that's the only combination. And we also realize that out of those two numbers, 5 plus 5 also makes 10. And that's it. This is fully factorized. Now, part B. Sketch the curve with this equation below. So that's the same one up here. Showing the coordinates of the points at which the curve cuts or touches the x-axis. Okay, so first things first, let's go ahead and understand what we're drawing. This is a cubic graph. So a cubic graph, and this is a positive cubic. Cubic graphs always start at the bottom, curve down and shoot upwards. A negative cubic starts from the top, curves up and then shoots downwards. So negative downwards, positive upwards. Okay, easy stuff really. So, and all we have to realize is that these x values here represent the points where the curve hits the x-axis. So let's have a little sketch. So just draw your graph like this, and just realize that our critical points is going to be when x equals 0 and x equals -5. When you've got two values are the same, instead of going through the point, it bounces on the point. So here's the value. So we've got x equals 0 here, and of course, this is x plus 5, so it'll be x equals -5. Now, because it's positive, we're going to move through it. So what we're going to do, so we'll start from here, start at the bottom, and instead of going through it, because then that'll be a mistake, because it's repeated, we bounce on it. So we'll be bouncing on this, and then curves upwards and then shoots up. That's it. Something like that. That's it. As long as you got the right kind of idea, it must bounce. It must not go through. If you had 3 distinct points, it'll go through one, go through another one, and then go across the final point. Simple as that. Okay, and yeah, that's it, I guess. Now, here's the main part of the question. So we've done this. So the points with coordinates -3 and 0, so when x is -3, y is 0, lies on the curve with the following equation. Now just take a moment and realize that this equation is the same as the previous equations, except now that x has transformed into x plus a. Okay, so if we had to think about this, notice how when we factorized the previous equation, we had something like this, yeah? Factorizing gave us this. So just writing this neatly, our original factorized equation was just x and then x plus 5 squared, just to make it simple. Now we can just realize that because x is transformed to x plus a, just replace all your x's with x plus a. So that would be the new equation. So the new equation is going to be y equals, instead of x, we're going to have x plus a. And instead of this x, we have x plus a. So we have x plus a, and then of course, plus 5, all squared. Now we know that this point lies on this curve, so we just plug this coordinate into this equation here, and find the two possible values of a. So I've already solved this as well. So scrolling down, I literally said at minus 3, 0 with the equation we just obtained over here. Plugging in x is negative 3, which I did, and y is 0. This equation becomes minus 3 plus a, and this one here becomes minus 3 plus a plus 5. Now 5 minus 3 is 2, so that's why I got 2 there. Now we just solve, and we equate this to 0 because y is 0. So therefore, solving this, we're going to have minus 3 plus a equals 0, so a equals 3. And 2 plus a all squared equals 0, and well, this means a is negative 2. And that's it. Two values of a right there. So yeah, guys, if this video also helped, give me a like. And this question's again helping as always. Give me a like and subscribe and share my videos to your buddies. Okay, 14. Ooh, so it looks like we're dealing with population now. Okay. So this one, we have to kind of think geographically here with these kind of questions, okay? So every time you got population style questions, think about what happens in real life. Okay, so let's go ahead and look at the text. So a town's population P is modeled by the equation P equals AB to the power T, where A and B are constants and T is the number of years since the population was first recorded. Make sure you guys note this down, especially T. The line L shown in figure 2, okay, straight line equation, illustrates the linear relationship between time and log 10 of population for the population over a period of 100 years. So this has just been recorded from time equals 0 up until some point into 100. So, and again, it looks like they're assuming the rest of it is constant. So this can actually go up to thousands of years, but of course, we don't know what can happen in 1,000 years. There could be wars and so forth. So population can change. Let's assume that we live in a piece of world and nothing changes. The line L meets the vertical axis at 0, 5, okay, intersects at 5 and has an x coordinate 0, and the gradient of L is 1 over 200, so m equals 1 over 200. All right, so far so good. So write down an equation for the line L. So this is straightforward. This is y equals mx plus c, okay? So let's just note this down. We know the gradient is 1 over 200. We know what y is. It's actually the y-axis, so log 10p. And we know x is technically t. So we're left with log 10p equals the gradient, 1 over 200, times t. So we could just say t over 200. And it's y-intercept, well, it's easy. We can see it intercepts at the point 5, so plus 5. That's it. So this is pretty much our equation right there for A. Now B, find the value of A and the value of B. Okay, so this is referring to the P equals AB to the power T equation. Now this is fine because you can already see that the log equation has P here already. So we can just substitute the variable P for AB to the power T. So we can say, okay, I'm gonna make some space here. So we've got log 10 and we've got now AB to the power of T equals T over 200 plus 5. So we can just say, for example, just look at the coordinates. So we got 0, 5 already, and you can just pick anything, since you can just plug in any value for t, and then as long as it's between 0 and 100, and you should be fine. So let's go ahead and say, hey, what happens when t is 0? So when you get t is 0, what do we get? So we're going to be left with log 10 ab to the power 0. So b to the power 0 is 1, so we're just left with log 10a equals, and then this becomes 0 over 200, so it just becomes 0 plus 5, so 5, and therefore we can solve this one. So we can say, you know, using the log properties, if we keep a in this position and raise everything by 10, so it'd be a equals 10 to the power 5. Now this is just log transformations, yeah? To invert the log, all you have to do is take exponentials across, so the logs cancel out, and then 10 raises up and 5 goes up. Think of it as a ladder case. You got a equals 10 and then 5 here. That's how I see it as a ladder case. So that's good. So that's one value, so 10 to the power 5. Now we got that. Let's see. We can also find value b. Now what I would do for this one, I mean, I would just pick something easy. I'll say, let t be 1 or something, because it's linear and you can pick anything on this line. So let's say, okay, when t equals 1, what do we get? Okay, so we get log 10, and then now we know the value a is 10 to the power 5, 10 to the power 5, and then t is 1, so we're left with just b. So 10 to the power 5b. Okay, so far so good. Equals 1 over 200 plus 5. I'm going to go ahead and simplify that in my calculator. And doing that, I get, well, it's kind of ugly actually. Okay, I'll go decimal. I'll go 5.005. Okay. Now, using the same idea, I'm going to use the log transformation. So I'm going to raise 10 up using the staircase method. So 10 goes up and 5.005 becomes a power. So doing it over here, we should get 10 to the power 5b. That was in the bracket equals 10 to the power 5.005. Okay, not bad. Now finally, just to solve this one, just divide 10 to the power 5 across, and you're left with b equals 10 to the power 5.005 over 10 to the power 5. And doing that in your calculator, so you should get, I should have wrote this in. Now this one, I'm not sure they want it in exact form because they don't specify, but I got about 1.011. So I got roughly 1.01. Let's say 1.01, yeah, 1.012. So three decimal places. You could also just subtract the powers if you want. You could say b equals, so 5.005 minus 5 is just 10 to the power of 0.005. Yeah, but that looks kind of ugly, so I'll stick with 1.012. That's it. Okay, part C now. So with reference to the model, interpret the value of a and b. Okay, so what this is talking about is from the p equals ab to power t model. Okay, so let's just note this down. Oops. Now, what actually helps when you write this down is the fact that you have the values now. So let's go ahead and plug the values in. We had a, which is 10 to the power 5, which is, in other words, 100,000 in the calculator. And b is simply some sort of multiplier, 1.012-ish, and to the power of t. Now, looking at this closely, if you see it specified, you can see that this is kind of like a compound interest formula, or a geometric sequence, basically. So we can say firstly that a seems to represent the initial population. So when time is 0, we get a value of 100,000. So a is always the initial population at time 0. So that's how it works. As for b represents a multiplier. So it's pretty much a multiplier of 1.2%. So if you just took off the 1.0, just took out the decimal bit, this is an increase of 1.2% per year. That's what we're working with. So the population is increasing by 1.2% per year. So that's all it is. So you can just write b is a multiplier which increases at this rate, whereas a is the initial population at time 0. And yeah, I put it down here as well, just to double check. Okay, part D now. So find the population predicted by the model when t is 100. Ooh, easy. Giving your answer to the nearest 100,000. So simply just plug in t equals 100 into our general population equation. So that means you're going to get p equals 100,000 times 1.012 to the power t. And when you get it, you should get about, I don't know, about 329 something thousand. Because we want nearest 100,000, it should be rounded down to 300,000. That's it, easy. So that's actually quite, quite generous when they give you a huge rounding figure. It's actually like very inaccurate, but cool. Now next one, find the number of years it takes the population to reach 200,000 according to the model. Okie dokie. So this one, well, you want to see when the population reaches 200k. So replace p with 200,000. So now the equation becomes 200,000 equals the general equation, which is ab power t, so 100,000 times the multiplier to the power t. And now we just solve for t. So here you can probably guess that we need to use logarithms. So I'm going to go ahead and write this down below. So let's go ahead and divide 100,000 across. So we get 2 equals the right hand side. So now we've got 2 equals 1.012 to the power t. Now to solve this one, just take logs on both sides. So taking logs on both sides, we get log 2 equals log 1.012 to the power t. Now thanks to the properties of log, the powers drops in front of the log term. So we've got log 2 equals t times log 1.012. And finally, just divide log 0.1 blah blah across, and you should get t equals log 2 over log 1.012. Yeah, sorry, I sound a bit tired here because I've just been doing this non-stop. So yeah, so putting this in the calculator, and what do we get here? So you get log 2 over log. You can actually use the natural log as well, so you don't have to use this all the time. But anyway, this should take roughly, and this is to 1 dp, 58.1 years. Okay. And now finally, I just realized I missed a part. Now finally, looking back here, we still got part E. This is easy. So state 2 reasons why this may not be a realistic population model. In other words, we're looking at the straight line. If you remember in the beginning of this video, or the beginning of this question, sorry, we said that this is just a simple straight line model. So thinking about carefully, we are assuming that this can go up for an unlimited period of time. So we're assuming a constant relationship. So we can't assume that the population growth is going to be proportional to the actual population size, because as one population size increases, the growth may not necessarily, be proportional and going across in a straight line. So this is unrealistic because it also lasts for 100 years, and anything can happen in 100 years. There might be loads of hazards, for example, wars, famines, diseases, and this alone will affect the population growth. It may increase the death rate, and reduce population births. So yeah, I just wrote a few answers which might be interesting, and I kind of looked at the mark scheme just to see if they're in line with this. So I said population growth may not be proportional to population size. So again, it changes over time. More population may actually reduce the growth, or job opportunities may reduce it as well, and so forth, or any economical reason. The graph assumes unlimited growth, whilst ignoring possible fatalities. For example, example, wars, famine, nationwide disease, etc. So yeah, what we just said. And of course, 100 years is just a ridiculous long time. Yep, this is crazy. I mean, imagine we're talking about up to 2100, and there's a good chance, God forbid, we don't know how far we'll live. And in 100 years, the countries that we live in today might not even be the same countries. Anyway, so that's it. That's really 14 done for you guys. Okay, number 15, guys. Here we go. So we got a curve C1 shown in figure 3 has this equation, okay? So it's a standard quadratic equation. So this is C1. And it looks like we also have a C2, another equation here, with this equation, which is actually a log equation. So half x plus the natural log of 2x. And of course, they're both non-intersecting. Now, before I skip this, at C1, we also had a random point P, which is with an x coordinate of half and a y coordinate of 2. So what I did here, and before I get to this line, I assume that the point half is here. I mean, it could be here or here. It doesn't really quite make a difference because this is not scale. And to be honest, you could actually work out where it is, because since this is a curve, you can find the turning point by differentiating and find an x coordinate. And if you did, this x coordinate would be 3/4, by the way, so half would have to be on the left side. But anyway, for the purpose of this, that's what we have. So let's call this point P. And it says that the normal to C1, so the normal to C1 at the point P. So here's point P. So the normal would be, this would be the tangent firstly, and the normal would be perpendicular. So it would be something like this. Well, a straight line, of course. Meet C2 at point Q. So this would be point Q. So that's so far all clear. So far so good. Now find the exact coordinates of Q. So what we could do here firstly is to work out what the normal to C1 is. So I would call this line y equals mx plus c at point P, since that's the normal to C1, right? Where m in this case is the perpendicular gradient. Makes sense because the tangent gradient is just regular dy dx. So the perpendicular gradient would be dy dx reciprocated and sign flipped. Now to work this out, we're looking over here. So we use the C1 equation, which is the quadratic, and we differentiate that using dy of dx, because this is the definition of a gradient equation, and you should get 8x minus 6. So this is very simple to differentiate. Draw the power here, so you get 8, remove the x here, and then constant disappears. Okay, now we say at point P, because that's the interest of the gradient, that's exactly what we want. At point P, x is a half, so plug in half into the equation, and you get minus 2 as the normal gradient, the tangent one. To get the perpendicular gradient, you just take the reciprocal of 2, so it's a half, and change the sign to positive, so m is a half. Now we have, if we put m back into the equation, we have y equals half x plus c. Straightforward. And now to find the y-intercept, i.e. the c value, just make c the subject, like I did here. Pick the coordinate p again, because we know one of the coordinates of p, which is here. You know, I should actually label this p actually. So this was p, yeah? We know the coordinates of p already, which is half and 2, so that lies on the line. If you plug it in, we can find the exact value of c, which would be 7/4. And then we can say, hence, equation of the normal of c1 is going to be half x plus 7/4. Now that bit is done. So now we can say that this line is going to intersect with this curve c2. So we can make a simultaneous equation between the new equation here, the straight line equation, with the log equation here. So I did over here actually, intersection between these two. Now because they both have y equals, like over here, y equals half x plus ln 2x, and the other one is y equals half x plus 7/4. If you just equate them because they both have y, it becomes like this. And then you can just say, okay, we can cancel the half x on both sides. And now we're left with 7/4 and ln 2x. Now this is easy, guys. Just take the exponentials on both sides, so the ln cancels out and you're left with an e to the power of 7/4, which I did over here. And lastly, dividing 2 across, you get the x coordinate of q, which is half times e to the power 7/4. Now, this one wants the answers in exact coordinates, hence the 8 marks. Now, to do that, just sub this into either equation, which is the line equation here, or the C2, because that's where point Q is on. Q is in either one of the two equations. Personally, I would use the simple equation, the line one, because it would be easy to solve. So I would use this equation, only because you have to multiply the x coordinate by a half. And let's be honest, if you times by a half, this just becomes a quarter, like I did here. So plugging in the x value into the line equation, I get y equals half times half e to the 7/4, close bracket, plus 7/4. And then just expanding this, you get quarter e to the power 7/4. And that's it. That's your x coordinate here and your y coordinate here. So guys, that was a quick, thorough explanation. You know, I try to make it quick and fast so you can actually get to the point of this. And yeah, if you enjoyed this video as well, please give me a like, and I shall see you in the next one. Alright, number 16. So, figure 4 shows the plan view of the design for a swimming pool. Ooh, interesting. The shape of this pool, ABCDEA, so the whole thing, consists of a rectangular section, which is the top half, joined to the semicircle section on the bottom half. Okay, so given that AE is 2x and ED is y, and that the area, i.e. both of these combined, equals 250 meters squared, show that P meters of the pool is given by this equation here. Alright, so a few things to do then, okay? I'm gonna just go ahead and try and get this all in the screen. Okay, so just what I always recommend for these type of questions is that, firstly, if they told you to find the perimeter, first write an expression for the perimeter of what we know and match it to this one. Secondly, if they talk about area, calculate the area and match it to the area of 250. So basically we need to form two kind of equations. Let's work with perimeters, since perimeter in other words doesn't equal anything. So we can say that perimeter here, firstly we got AE, which is 2x. We also got the height, so this is y, so this side will also be y. Now, because this is a semicircle, so half a circle, we need to know that the area of a circle is always going to be 2 pi r squared, and that the circumference of a circle is 2 pi r. Now, because we got half a circle, so the half part would be half of 2 pi r, which is just pi r, literally, and that just covers from here to here, just the half width. Now, we're working in x's, yeah? Now, one thing to note, what is the value of the radius? Well, if we pinpoint this as the center of the circle, we can see that the radius, if we stretch it across here, or here, or here, and so forth, is going to be exactly half the length of 2x, meaning that radius is actually just x. So we can update pi r as being pi x, since the radius value is x. Okay, so that's the value right here. So now we've got everything. So we can say that the perimeter is going to be 2x plus y, which is 2x and 2y, plus pi x. And that's it. That's 3 things done. Now looking at both equations, we can see that the y has been transformed to 250 over x plus this, and pi x also transformed. So basically 2y plus pi x will need to be updated to match this one later on. So before that, let's look at the area now, yeah? We know that the area equals 250, so we can right off the bat say 250 equals something. So the area of both of these together, well, the rectangle bit is just base times height, so it'll be 2x times y, so 2xy, easy. Now, again, this was a semicircle, and we established that the area of a circle is pi r squared. So half a circle would be half of this, would be pi x squared over 2. Remember, x is the radius, yeah? And that's it. Now we just add these two together. So we can say that the area, which is 250, must equal 2xy and pi x squared over 2. Now, what happens here? Well, the final equation is in perimeters and x, so the one thing we need to get rid of is the y. So what I would recommend is make y the subject for this equation and plug it to the first equation. And that's easy. To make y the subject, subtract pi x squared 2 over cross and divide 2x. This will give us 250 minus pi x squared over 2 all over 2x. Plug this into the first equation. So let's have a look. So I'll probably need some space, don't I? Actually, I'll do it here. Plug into the, okay, let's see if we can simplify this actually. So this becomes 250 over x, so this becomes, yep, leave as 250 over 2x minus, so we got pi squared over 2 over this 2, so this would be 4, so it'd be pi x squared over 4x. So 2 here multiplies with that, and all of this equals y. Right, now plug this into the first equation, and when you do that, let's see what we get. So we should get, let me change the color of the pen. Well, have a go at this and see what you lot get, yeah? So you get 2x plus 2 times all of these, so it'd be 500 over 2x minus 2x squared over 4x. Well, you know, let's cancel 1x right now, so this disappears. Double this one, you get 2 pi x over 4, and cancel the 2's, you get pi x over 2. Easy. And then simplifying this down, so 500 divided by 2 will give us 250 over x. And yep, that's it. I think we've done it, isn't it? Okay, let's see. Oh yeah, we haven't done it yet. Oh yeah, and we also need to add plus pi x, so plus pi x. And when you do that, this becomes a positive plus pi x over 2. Okay, part B now. So explain why x is between 0 and square root of 500 over pi, which is about 12.6 by the way. So this is just understanding how x and y represents here, yeah? When we look back at the shape, we can see first here, this is all to do with lengths, perimeters, and areas, yeah? X here represents a width length, and y represents some sort of height, or a base length. So first things first, when it comes to lengths and distances, we should always recognize that x and these values must always be positive. So right off the bat, we could just simply say that x must be positive and y must be positive, yeah? Now, looking back at the part A equation, we somehow formulated this, right? Now, if we assume that y is bigger than 0, we can say that this equation is bigger than 0. And what that means is that we have all of this now, 250 over 2x minus pi x over 4, all greater than 0. And yeah, that's it. Now, all you have to pretty much do is simply solve for x. So literally plus this across, make x a subject, and eventually you'll come to the conclusion that x is less than root 500 over pi. Now, I could go ahead and do this now. So move this to the right and, you know, just tighten this up. 250 over 2x is greater than pi x over 4, and blah blah blah. Eventually you get to x less than root 500 over pi. Okay, that's it. I believe that's all we need to really pick from there. So let's focus on the main part, point C, yeah? So find the minimum perimeter of the pool, given your answers to 3 significant figures. Okay, so minimum, always spot this keyword. This literally means to differentiate, always, yeah? So in this case, dp over dx, because we're working with perimeter. Always do this, yeah? Always differentiate. Reason why is because when you differentiate, you find the turning point or the gradient, and that value pretty much maximizes your value. Well, just differentiate, yeah, just keep it simple. So here we go. So let P equals the perimeter equation, so we had it over here. Now always write it in the standard form so you can differentiate. So in other words, get rid of the fraction over x, make it x to -1, and just tidy up a bit so you have clean x variables, yeah? Finding the differentiate this first time, so dp over dx, 2x becomes 2. The next term, the -1 goes in front because you drop the power and it's subtract by 1, so you got -2. And the other one you just take off the x, because remember pi over 2 is a constant. Don't differentiate this or get confused by it. And yeah, now all you do is set this to 0 and find the value x, which guarantees the minimum. So that's the point. When you set this equation to 0, you're basically finding the minimum point here. That's what we're looking for, literally, the minimum point, or the minimum x coordinate, which will make this at the curve at its lowest point. That's how it usually works. So when you set this to 0, you just solve for x. So if you're not sure how to do this, what I did is plus 250 x -2 to the right and convert it back to its usual form, so 250 over x squared. Then I just times x squared across and divided 2 plus pi over 2 across, like I did here. Smash this in the calculator and then square root. And you should get 8.367, and of course plus minus. But because we established in part B that x is a length, and because we know that shapes lengths are always positive, we only keep the positive answer. And finally, to get the minimum perimeter, using the minimum value of x, which is over here, the minimum x value, plug this into the perimeter equation and voila. Replace x with this and you should get 59.8 centimeters to 3 significant figures. Done. And that's it. And here we go, guys. Number 17, the final question of the paper. Whew. So well done, guys, for coming this far. But without further ado, let's go. So we have a circle C with center of -2 and 6, which passes through the point 10, 11. So just a quick recap, the center is always given in this notation A and B, where A is -2 and B would be 6. So I just did a little demonstration here. This middle point here, the center would be A, B, or -2, 6. Now show that the circle C, so the same circle, also passes through the point with 10 and 1. Now this is straightforward. To prove this statement, the whole idea is to show that they have the same radius. Because if this point was on the circle, and this point was on the circle, and this is the center, it must mean that the distance between them must be the same. So I just called it R for the radius. Okay, so that's just a little demonstration. So all you have to do is firstly write down your circle equation, which is of course x minus a all squared plus y minus b all squared equals radius squared, with a and b being -2, so -2 is +2, and minus b would be -6 equals r squared. And now you just test it. You said, okay, so if we plug in firstly the point 10, 11, what happens? So when x is 10 and y is 11, you just deduce the equation and you get 169, which must equal r squared. So therefore, square rooting this will give us a radius of 13. And now we do the same with the point 10, 1. So we say, okay then, so at 10, 1, we replace x with 10 and y with 1, just like you did above. And again, you get 169. It's kind of obvious here because you can see that the difference in the y is just 5 for both. So of course you get the same result. And that's it, you proved it. So therefore they have the same radius, so proved. That's all. Now, here comes the final main meat of the paper, yeah? So the tangent to the circle C at the point 10, 11, so over here, meets the y-axis at the point P. I'll show you how I did this. And the tangent to the circle C at the point 10, 1 meets the y-axis at the point Q. So you've got two different tangents. Now, this is the main part. Show that the distance from P to Q, so when they meet the y-axis, is 58. We have to explain every step. Okay guys, so let me show you what I did exactly. Okay, so here we go. So here's everything. So I put the center over here, -2, 6, and of course I put 10, 11 and 10, 1 over here. Now, the reason why the y-axis is between these two is because firstly, the x-coordinate for the center is negative, so it's on the left side of the y-axis, whereas the 2 points are positive, so it's on the right side. Also, if you note carefully, when I drew this line, the radius, here is your tangent, because one thing we need to know about tangents on a circle is that it's perpendicular to the radius, both of them. Makes sense, because it has to touch one point, it's always perpendicular to the radius. And that's fine. And so the key idea is to firstly work out the equation of this line here from the center to this point where 10, 11 is, and find the equation of the line from the center to 10, 1. So let's work out that step by step and you'll see what's happening. And then we can finally work out the distance from P to Q, which is completely vertical, by the way, so that's good. It'll just be a subtraction of the y coordinates. Now, let's start with the line from minus 2, 6 to 10, 11. So using your general y equals mx plus c, so here's the line, where m is the gradient, the change y with change in x. We just find the difference in coordinates from minus 2, 6 and 10, 11. So 11 take away 6 or 6 takes away 11 over the change in x between minus 2 and 10. That should give us 5 over 12, easy. To find the value of c, the intercept, so where it hits the y-axis, which is this coordinate right here, it just rearranges this equation and makes c the subject. So I did y minus mx, and we have the value m now. Y and x could be any of these 2 points. I'm just working at the center. You could work with that with 10, 11. It should be fine. So plug in all the values, y for 6, x for minus 2, and the value of m, and you should get 41 over 6. And therefore, this point here would be the y-intercept. So you can actually say that this coordinate here is 0 and 41 over 6. So I'll put it over here actually. You can see this coordinate right here. I just called it a as well. Now for the second step, for the second equation, do the same thing here. So from minus 2, 6 to 10, 1, follow the steps carefully. Find the equation of the line where the gradient is this, minus 5 over 12, the difference in the points, and find the value of c using the same method, where y minus mx. And again, you get 31 over 6 this time. So this would be this coordinate here. So this upper coordinate here is 41 over 6. This lower one is 31 over 6. And of course, the x coordinates are 0. Now, why do we need this? That is probably what you're wondering. So I've called this one D and this one W. The key idea is to find the value of AP. So this is basically Pythagoras Theorem. You know, we could just call this length AP, which is well done. So the key idea is to find an expression for D squared plus W squared equals AP squared, which I put over here. So for D squared, you could firstly just work out use the distance formula to find the difference between these 2 points, which I did over here. So between 10 and 0, 10 minus 0 squared plus 11 minus 41 over 6 squared. And then for W, you find the distance between 10 and 11 and when the tangent hits the y-axis. I just called it 0p because when something hits the y-axis, the x-coordinate is 0. And it's p because I need to just give it a name. So when you do that, find the difference between them, you should get something like this. W squared equals the following. And for AP squared, do the same thing. Find the distance between the coordinate of A, which is 0, 41 over 6, and P, which is 0 and little p. So same story. Now this is where you get your answer for P. And this is actually one of the correct answers too. To do this, just use Pythagoras theorem. So AP squared equals D squared plus W squared. Substitute the value for AP squared. So I already calculate AP squared. Well, I didn't really. I just put it over here because this term is 0. And for D squared, I literally put this all in the calculator and got 4,225 over 36. Put it there. And for W squared, well, I did the same thing. The first term is 100, and I haven't expanded the second bracket yet. Now all you do is just open the brackets, open this quadratic to get the left hand side, which is over here. Open the quadratic on the right hand side and collect like terms to get something like this. Cancel the p squares across, so let me actually just show that. So these ones go. And then you just solve for p. You know, you can just plus 22p across, subtract this constant term to the right, divide, and then just isolate the p and you should get 35. So I would do this step by step, but this will take a while and it's best to just see the deductions so you guys can try out as well. And now that's for A. So basically 0p basically becomes 0 and 35. So that's what we wanted. Now for the second equation, it's the same thing. So just looking back at the general graph, we worked out this coordinate. So we know that P here is 0 and 35. Okay. Now we need to find the coordinates of Q. So we're going to work with the bottom half. So the tangent from 10, 1 to 0Q. Okay. So just repeat the procedure. So again, I call this length here M between Q and 10, 1. And I call this length N between B and 10, 1. So this is the tangent points. No, so this is the part where the circle is, yep. The Q part is the tangent point. So using the distance formula, so I said let M squared plus N squared equal BQ squared. So somewhere over here. Yep, bq squared equals n squared plus m squared. Find an expression for n squared, so using the distance formula for every single line. So m would be, for example, m squared equals the distance between 10, 1 and 0q, which looks like this. Subtract the x coordinate squared plus subtract the y coordinate squared, and do it for each one. Eventually substitute all of these in like I did for the top one. Replace bq squared with whatever you got here, m squared with whatever you got there, and n squared with whatever you got on the first line. And then solve this for q, and voila, you get minus 23. And then you realize, okay, if this is 0 and minus 23, and because this is a vertical line, remember y-axis is a vertical line, you could just subtract the y coordinates. So 35 minus 23 will give us 58. Done. And that's it, guys. That's literally all I can say for this question. I hope this explanation was clear. I know, of course, solving it step by step would be nice, but I thought I'd try it this way because it did take quite a while to deduce, and there's a lot of steps. So yeah, anyway, thanks for watching, guys, and if you enjoyed this video, give me a like, subscribe, share to your friends, and I shall see you guys in the next papers. So have a good day and ciao.